Hi everyone. Today I'm going to show you the proof of how to find the sum of a geometric series. So a geometric series is a set of entries with a common ratio separated by addition. So it's the addition of a geometric sequence. So the terms are going to go up by multiplication. We can multiply by a fraction to make them smaller. But let's see how the proof works. So we're going to figure out, just starting with 5 terms, how do we add the series when the sequence is given by 3 times 4 to the n minus 1. So I could put 1 in here, find the first term, and I can put 5 and find the last term. Now I can't just add them up and multiply by the pairs this time. Doesn't work. It's not like arithmetic series. So let's write out the terms. So 3, 12, 48, 192, 768. Now we're going to do a little bit magic here. So I'm going to multiply every term by the common ratio, which is 4. R is 4. My multiplier is 4. So left side becomes 4 times the sum. And then I multiply 3, 12, 48, 192, and 768 all by 4 and get these new 5 terms. Now, if we notice something, 12, 48, 192, 768, they're all here. This has a 3, and this has a 3072. Okay, we lost the first term, but we gained a new term. We gained term 6. Now, since I see a lot of terms are in common, in order to eliminate them, I'm going to use elimination. So I have what the sum is, and I have 4 times the sum. So I'm going to flip these equations and then subtract downward. So let's flip the equations. Then we're going to subtract downward. You're going to see a lot's going to cancel out. Those cancel out because they're all common. So we're left with, on the left side, 4s minus 1s is 3s. And then the right side, we're left with 3072 minus 3. Now our goal is to get the sum of 5, to get this by itself. So what we can do is just divide by 3. So we have this 3072 minus 3 divided by this 3 in front. And you get your sum is 1023. Now our job is to put what we just did into a formula. So this 3072 is going to be term n plus 1. So the term after. This 3 is going to be my first term. And this 3 we're going to see comes from r minus 1. So once again, this 3072 is the term after the last one. This 3 is the first term. And we got this 3, which is this 3 up front, by doing 4 minus 1. So r minus 1. So this is how I like to think of the formula. I need the term after the last one, the first term, and then I need r. Now the textbook provides a slightly different formula, but it's the same thing. They like the first term, the multiplier, and the number of terms. So either way, you need to know the number of terms, you need to know your ratio, and you need to know your first term. Mine, you need to know the term after it, which you can just take the last term and multiply it by the ratio, or you can use the textbook formula. Both formulas are equivalent. I like mine because, okay, there's no distribution. I think it's a little bit cleaner, but they're both the exact same and they both will work. So you'll pick a formula that you like, and this is how we find the sum if it's a geometric series.